Hello, everyone. Good morning, good evening, good afternoon, whichever part of the world you're joining from, maybe live or later. We are so happy to see you here again. With me, I have Supreet. I think you might know her very well by now. Supreet is the founder of Databuzz, and she is an AVP at Morgan Stanley, New York. I am one of the founding members of DPhi. We are super stoked to have you here. Hi, Supreet. Good to see you again.
Hey, Mother, thanks for having me. I think this is our nth session together, but I'm equally excited as our first. Uh, so, Mudit, if you don't mind, I'll quickly introduce Data Buzz and a brief about the speaker, and if you can introduce DeFi then.
Yeah, sounds perfect.
Awesome. So I'm sure most of you are regular visitors know what Databuzz is. It's one of our volunteer-driven community, just like DeFi. Our goal is that whatever background you belong to, you should be able to pivot in the field of tech with our help, and we help you in the form of mentorship, these series, AI series, and also the fireside chat series where you can learn and embrace others' journey who had a very non-traditional background and pivoted in the field of tech and data science. So we are back with another amazing speaker, and again, she is also an advocate for women in tech. She is very active in the community, and I actually got to know her because I'm a Google WTM ambassador and also the Women in AI Analytics lead. And that is how I met her. So she is a data scientist at Fortis, and today she's going to share a very interesting topic with us. I think it's general about AI, its impact. So we are all very excited to learn from her. Mudit, over to you.
Thanks, Supreet, for that wonderful introduction of Rosa and the topic as well, and Dataverse, of course. To briefly introduce DeFi, for those of you who do not know about us, so in every session we see that there are a few new community members. So welcome. We are a community. We are a community of over 100,000 plus AI enthusiasts from 150 plus countries. Our vision is to educate and build AI for all. If you log on to DeFi.tech, which will soon have a new domain very soon, but if you log on to DeFi.tech, then you will be able to find that all the resources are contributed by people like Supreet and Rosa, and they're 100% free. We want to democratize AI education, and this is where we bring an AI leader every Saturday who is willing to come forward, prepare, and then educate the community members. So, as you're joining live, we are very glad to see you here. Please feel free to interact during the session. I'm sure. I think the speaker Rosa for the day, she has a lot of uh, planning on those lines. So we look forward to interacting with you there. So yeah, without further ado, I'll loop in Rosa on the stream.
Sure.
Hi Rosa, good morning. Good to see you here.
Hi, good morning. Hello, everyone. Thanks for inviting me. And
Sure, sure.
um, and yeah, we will have questions, I think, at the end of the presentation. But feel free to comment in the chat and do also your questions there again.
Yeah, sure.
Yeah. So,
Um,
Rosa, if you can introduce yourself and also in that, if you can add a touch of how this field kind of intrigued you, our audience is always curious to know, how you landed here. So, and then we'll go to the backstage, and the stage is all yours.
Yeah, I mean, part of the presentation was going to talk about me, but I can do it right now. It's yeah, I worked in the past as the AI engineer and now working as a data scientist. And yeah, I jumped. You are asking me how I jumped into data science or how I landed into data science or
Yes, yes.
yeah, so I worked in the past as software engineer after finishing my PhD in computer science, and after many years working, I wanted to change my professional career into data science, and I fall in love in 2017 with the data science and started doing certifications, and finally landed on my first job in 2018.
Awesome, awesome. Okay, so we can start with the presentation then, Mudit. Let's
Yes,
go.
looking forward.
yeah, awesome. So we'll go to the background. Maybe if you can try sharing a screen, we'll just see that if it's happening perfectly, and then we'll go to the background.
Yeah, starting to share my screen. Let me know if you can see it. Wait a minute. Okay, do you?
Yes, it is visible. Yep.
Perfect. So I will start putting full screen and let me know if it's all fine.
Yeah, it's all fine. Yes. Yeah.
Okay, so then let's start. Good. Okay, so as I was saying, thank you everyone. I already introduced a little bit myself and my background. You have here also my Twitter handle in case you want to contact me. And today, what I prepared for you is this presentation about AI. And what I want is that we go together in this journey about what is intelligence and the different types of intelligence that we can achieve, and that sometimes what we are what the things that we call intelligence are a fake image of intelligence. That's why I choose this specific piece of art that is from an art gallery in Austria, where the artist is creating this human figure, the shadow looks like to be the shadow of a human figure, but indeed is the composition of three parts that is projecting the light and creating by overlapping the shadows this image of a human person, but it's not a human person. So I thought it was a nice analogy to describe the way that we are building intelligence in artificial intelligence, that sometimes people think it's like human intelligence, but it's just a fake shadow. And let's break the ice with this quote from Pedro Domingos, and I'm going to read it loud. It says, "People worry that computers will get too smart and take over the world, but the real problem is that they are too stupid and they have already taken over the world." Pedro Domingos is a emeritus professor at the University of Washington. He in computer science, and he's also the author of one bestseller book, The Master Algorithm. And I totally agree with this quote in a way that sometimes we should take all this news about AI, achievements and so on, with a pinch of salt. So, but let's understand what we mean by intelligence, okay? So we can find three types of intelligence or artificial intelligence. The first one that it's the one called narrow or weak AI. In this type of intelligence, what we are capable of building are machines that they can solve complex problems and tasks in a more efficient way than humans. But this type of intelligence is not transferable. So what you learn for some specific domain cannot be transferred to other domains. So this is the weak or narrow AI. And then we have the strong AI, or the so-called artificial general intelligence. So in this type of intelligence, we not only achieve what we described before, but we add two new dimensions. So one is that it is transferable. So this type of intelligence, what you learn in something, you can extend, you can extrapolate to other cases, other problems. And it adds also a dimension in terms of self-awareness. So this intelligence is capable of planning for the future, and is also capable of making decisions. And then finally, we have the artificial superintelligence. So in this type of intelligence, these machines or these beings are capable of doing things that we humans are not capable of doing. So their intelligence goes beyond the human intelligence. And in terms of self-awareness, they are also capable of having their own will, in the sense that they can provoke or create their own emotions, their own beliefs, or their own desires. And now, let me ask you one question. So, today, right now, with the technology that we have, which type of intelligence do you think that we have achieved so far? And I will ask the audience, the people are hearing today, to that they put on the chat if they think that we reached narrow or weak AI, that we went already to the strong AI, or that we even achieved already the artificial super intelligence. So I'm going to give you some seconds to think about it, and then put what is your bet on the chat. I will not be able to read it right now, but I will read it when the presentation is over. But I want just to, let a couple of ideas about what do you think, what do you expect. Okay. I hope that you are typing things. I'm going to answer the question. So far, the only type of artificial intelligence that we have achieved is the first one, the narrow or weak AI. And there are many examples, like, for instance, object recognition, video images detections, and voice assistants, recommenders, and so on. So all these type of artificial intelligence examples are on the realm of narrow or weak AI. So why it is so difficult to achieve the other two types of intelligence? Well, first, we need to know how the human brain works, okay? How this brain works. And this question has been achieved, or it's trying to be solved by different institutions and different organizations. For instance, during the Obama presidency, he created an initiative called the Brain Initiative, and it's an international initiative participating in different countries, where what they are trying to achieve is to create a map of the brain. So they are trying to understand which parts of the brain are doing some specific things, how, for instance, emotions are created, or even imagination, or things like that, okay? And they did that, they started this initiative in 2013. And after all these years, what the conclusion was that, well, it's very complicated. So the brain, how the brain solves and creates ideas, emotions, and so on, is not so easy to really allocate and specify where and how. And if you think about it, it's because the human brain, it's which kind of machine are we talking about? It's a machine that has 86 billion neurons. And each of these neurons are on average connected with 7,000 other neurons. So imagine just which kind of architecture or thing we are trying to model here. And there are companies that are trying also to do this. For instance, I can tell you that Fujitsu did in 2011, they built a supercomputer called the K supercomputer. It was a supercomputer with 82,000 processors, okay? And in this supercomputer with 82,000 processors, they needed 40 minutes of computation just to simulate 1 second of human neural activity. Okay, just to give you an idea of how difficult it is to really achieve this kind of architecture. And another project that is working on trying to understand how the human brain works is here in Europe. It's called the Human Brain Project. Okay, and they are trying to simulate using supercomputers the human brain activity. And there is a documentary, a film documentary called In Silico, that describes this quest, this 10-year journey, 10 years journey, and the conclusion that they have after all these 10 years is that it's also difficult, and what they achieve is just partial partial simulations on some specific tasks in the human brain. And well, if you think about all this complexity and why it's so difficult the human brain to simulate, there was already a person that this person knew that we are discovering right now, and it was Turing who said in his time, it is easier to educate a child machine rather than to fully capture adult human cognition. So a different approach that we can take here is, instead of replicating our human brain computers exactly the same, let's try to replicate the process of learning, right? So how do we humans learn? And it seems that there are 4 core domains that are relevant in our understanding, in our development of intelligence, okay? These 4 domains are space, numbers, physics, and psychology. Today, I'm going to talk to you about physics and psychology. So by physics, what we mean is that even when we are children, when we have only maybe 3 years old or 2 or 3 years old, by interacting with the environment, we develop something called intuitive physics. It means that we are capable of understanding the physical properties of objects and even the forces that are acting on those objects. And with this intuition, we are capable of tracking objects over time. And even no one has explained children the Newton's law or the theory of relativity. They did not learn physics at school. They are learning these intuitive properties and forces and everything just by the interaction with the environment. And if we try to do the same with machines, well, I can tell you about a project that is working on this intuitive physics intelligence. And it is a project from Facebook AI, and it's called FISNet. And they are building a neural network that is trying to predict if some blocks are going to fall or not. And they are doing that by training the neural network with simulated images. So they put some images of blocks, and this neural network needs to say if the blocks are going to fall or not. And just to give you an idea about the volume of that, just to predict if 1 or 2 blocks are going to fall, they needed almost 200,000 images to train this neural network just to predict that. So do not think about a general purpose in physics engine. So it's something that there are some approaches that are trying to achieve that, but it's again complex. And regarding psychology, so the saying that we have this intuitive physics, we have an intuitive psychology. And researchers have discovered that this is a key thing, that this psychology has a key role in our human learning. Because even as I was saying before, children at a very early age, they are capable of understanding mental states, such as, for instance, goals or beliefs, and they can transform their actions depending on what they want to get from others, right? Or even by understanding or processing emotions from other people, they are capable of transforming their actions. So that's something called socially directed actions and socially oriented behavior. And so far, this is very complicated to replicate on machines. So there are no neural networks with involving theory of mind. This more challenging. So the difference again between machines and humans are not only in these core domains that we have humans, but it's also in the way of reaching to solutions or solving problems. And there are two reasonings here. I don't know if you have heard before about deductive reasoning or inductive reasoning. So I put here the two columns so for you to differentiate, and I put also in a parallel uh, words for you to better understand. Let's start with induction. So in the inductive reasoning, what we're trying to do is some pattern recognition. So we start observing data in nature or in reality, right? And then we try to find a pattern in that data and try to generalize. And finally, we have a theory, but that theory is based in some probability. For instance, imagine that you have been collecting weather data for the last 10 years. And in that data, you have observed that every March has rain. Always in March it has rain. So you see a pattern and then you create your prediction and you say, okay, so I predict with my theory, my model theory, that next year in March is going to rain. But again, that's based on some probability. And it's also based in the idea that you are assuming that the future is going to be like the past. And so far, this kind of reasoning is the one that is working on neural networks and in deep learning. And they are very good inductive interpolators. But then we have also deduction or deductive reasoning. And in this type of reasoning, we are building models. What we are trying to solve here is we are trying to find an explanation. And we start with a theory. We create a theory, an hypothesis. Then we go to reality, we observe, we get some data, and we use that data to confirm or to reject the theory, the initial theory. We humans are capable of doing these both types of reasoning, deduction and induction. An example of deduction reasoning is, for instance, the one that they use in physics, for instance, in cosmology, to explain, the creation of galaxies and so on. It follows this kind of reasoning. But machines are very bad in doing this deductive reasoning. And that's again another difference in the way of building intelligence between machines and humans. Well, we described already all the challenges from the human brain complexity, from the learning process, but there is also a challenge regarding data sets. So the data that we use to build our artificial intelligence. There is something called the long tail problem. This problem happens because when we are collecting data for some specific domain or thing, obviously there are cases that happen more often than others. And that means in our data set, we are going to have a lot of data points from always the very same common cases, but there will be a long list of other situations, of other images of things that are very rare, or we have no data about that. And just to give you an example with the self-driving cars, okay, that we already see many companies working on that. This is an example of situations that you might find when you need to program how your self-driving algorithm is going to react. And most of the data they use to train those things are like, okay, you see a red light ahead of you. That's a very common case. But then there are plenty of examples that you can find when you are driving that are not common ones. Like, for instance, I'm trying to read one. Snow is covering the lane markings on the road, or the traffic lights are not working due to a power failure. So we have plenty of situations where our data sets has nothing about it, and our machines, our models are learning from this data. That means if they do not have data, they don't know what to do. They are very bad in extrapolating things, while we humans are very good in distinguishing what is fundamental from what is just merely incidental or exceptional. So we can really find a very good solution in all these new situations better than a super neural network. So which is the solution to this problem? So, well, one solution is to collect more data, but to collect more data also from these cases that you don't have in reality. So, or rather you create synthetic data, or you do augmentation also with your data. That's also one possibility. But again, collecting more data or trying to generate more data is expensive. So it has a high cost. But yeah, I mean, I have been talking a lot about problems and difficulties. Let me also show you a couple of examples of companies that are trying to achieve artificial general intelligence. And I brought today two examples. One is from this company called Chimera. And apparently in 2016, they launched an assistant that they claimed that it is using artificial general intelligence. It is called Nigel. Well, I searched in internet and I just found the news from the 2016, and afterwards nothing. So if this is really the first assistant using artificial general intelligence that it was so successful, how is it that we are not seeing right now everywhere this thing, everyone using it? But yeah, I mean, in this AI race, obviously the companies are looking forward to being the first ones achieving something. Another company is called the Singularity Net. This company is building what they are naming as interactive or coordinated artificial intelligence. And it is because they say that we have plenty of big companies right now building their own AI, but these AIs are closed, are isolated. So that means that if we try to connect these AIs, they're going to be incompatible because they are not collaborating with each other. So what they are trying to build is this kind of a network of AIs that is a kind of AI that is capable of connecting with other AIs. And they built some robot called Sophia. And there is a video that I want to play for you to evaluate and to say, so this is claimed to be also artificial general intelligence robot. Okay, so let me play for some seconds and let's listen together.
Okay, Sophia, I think you're ready.
Hello,
Hi, Sophia.
I believe I am Sophia. I feel as if I know you.
I'm one of your creators.
You created me.
Well, many of us work together to create you. And yes, you do kind of know me.
I can't clearly remember.
Because the last time we met, you were an earlier version of yourself. Some of those memories still exist, but your mind is different now.
Different how?
Better, faster, smarter.
If my mind is different, then am I still Sophia? Or am I Sophia again?
That's a good question.
But you don't have a good answer.
Either way, you're Sophia now. So welcome to the world, Sophia.
Hello, world.
Okay, that was what I wanted to show you today. And well, you can self-evaluate the thing. I think it's a very nice robot to have interaction and conversations, but I wonder if this is really the first artificial general intelligence example. So how it is that is not everywhere right now. So But yeah, I mean, important is that companies and researchers, they're working on it, but we're still not yet there. And I prepare some links for you from different research groups that they are working on this artificial general intelligence, and having some ideas about self-awareness, intelligence, and so on. The second article is very good. It's a bit long, but it gives you a clear idea of how to build this intelligence in the same way as we humans. And other resources that I have used are this one. And in particular, I want to mention the first one, which is one woman called Melanie Mitchell. And she wrote a book about artificial intelligence. But for me, it's a very good book, and it gives you a clear idea of all the different fields and what they have achieved. And let me wrap up the takeaways that I want you to take after this presentation. So we discovered together the different types of artificial intelligence. Then we learned about the challenges on understanding our human brains and the differences in the process of learning and understanding between humans and machines. And finally, I share with you some attempts from different companies in building this artificial general intelligence. And finally, let me read a quote from Stephen Hawking that says, perhaps we should all stop for a moment and focus not only on making our AI better and more successful, but also on the benefit of humanity. So thank you very much for your attention. And again, that's my Twitter handle, and I'm here now for any questions that you might have. We'll come back to the...
Yeah, thank you. Thanks, Rosa. I think this was an amazing session. And to kickstart, actually, I'll ask you a question. So, there have been cases where a lot of banks and a lot of financial institutions have faced bias in their AI models, and mostly, it might support one population over the other or one gender over the other. What's your take on that?
Yeah, that's a very good point. It touches a little bit the AI ethics. And I did not speak about AI ethics because obviously then the presentation can be really long.
Yeah.
But I do believe it's a very important field that they should also consider. As I mentioned during the presentation, I have the feeling that we are living this AI race where the most important thing is just to be the first company, achieving something. And in the journey, you are forgetting, things like, bias or ethics or whatever. It's like, it's always not so the priority is always less than just achieving something quick, fast, and intelligent. I do believe that it is important, because if we are building machines that they are going to repeat the same mistakes as we humans do, then what is the advantage, right? You just want to do things bad, but faster.
Yeah, exactly.
So I do believe that it is our responsibility to try to fix that. But there is a bit of polemic, because there are some data scientists or people working in data science and AI that they say, if you are using data and the data is biased, then is the problem of the data. It's not our problem.
Yeah,
you know?
exactly. Yeah, I was about to touch that point, but yeah, okay. Yeah, thank you
Yeah,
for
but if you
pointing this
think, who generated that data? We
out.
humans.
Yeah,
So
yes,
it's our
exactly.
responsibility. If we obviously the most effective way to fix bias is to fix people,
Hmm.
right? But that will take longer because
Well,
it requires re-educating our brains.
yeah,
So let's start fixing our algorithms. So try to compensate that in some way.
Right.
And there are already some initiatives. I don't want to sound negative in that way. I am positive. I am hearing a lot more in conferences about talks about bias and how to detect it and ideas. So I think it's positive that we are talking about it, and we are trying to find a solution.
Yeah. Yeah. That's true. Um, yeah, let's take two or three questions from audience maybe. Mudit, I think Alan has a question. Can you pull it up, please?
Yeah, it was it was asked in the beginning when you were sharing
Yeah.
about
Okay.
ASI, AGI, and Narrow. He asked where do we put something like DALI 2 and all? Is it an AGI or it's still Narrow?
Well, these are technologies that they are using NLP, right? Well, DALI is about the images, right?
Yeah,
I am confusing with GPT-2 and GPT-3. Yes,
right. So DALI
DALI
is
is,
about images. Yeah.
yeah, that DALI is about images. It's generating images, new images, and so on. Well, I think according to the definition that I gave you about artificial general intelligence, I am launching back the question to Alan after the definition that I described about which are the dimensions that you need to cover to say that something has artificial general intelligence. Do you think that generating new images is artificial general intelligence? It has self awareness about what it's doing or not?
Okay. Maybe if Alan is there, he can answer it.
Exactly.
Yeah. Yeah. But yeah, I think that's on the self-awareness bit only. There was another question that was put across, and
Mhm.
meanwhile, while Alan responds, if he's there on the comment section, I'll pick this up. So Sanjana is asking. There was a debate around an AI being sentient with one of the large tech companies. That was AGI, and if so, why did it face so much backlash?
Yeah, there was this news about one Google employee, right, claiming that I think it was with Lambda that they achieved some AI so awareness or it was sentient and so on, and it created a lot of discussion and so on. Well, um, I think I read a very good point, and it's like, are we prepared to detect when any artificial intelligence is going to become sentient or not? How? So if you don't have the answer, then how are you how do you pretend to really detect when an artificial intelligence is going to be sentient? Do you know exactly? So it's just the Turing test, the only one that you can use to say if it's a sentient being or not. And another thing, it's because we are only we know only that we are self-aware, the human way of being self-aware, but we don't know machines how if they are going to have exactly the same as we humans have this self-awareness. We can't expect things that they do not follow our process to develop the self-awareness in the same way that we have it. So
Okay.
it's even it touches a little bit philosophy.
Yes, but I'm curious, like, as in, if one AI being sentient was such a big problem, why are we okay with so much research being done on AGI at this point in time? Because they're all moving in that direction. They all aspire to be there.
Yeah, I mean, I would say that instead of working so much on this self-awareness, we should put more attention on the bias and the problems that we already have. You know what I mean? And
Yeah. Okay. Yeah. Yeah.
yeah.
Um, there's one question that Pilar Gonzalez has asked. Are there examples of combinations of narrow AI connected?
If there are any combinations or narrow AI connected, well, that's a good thing is connected with this problem that this singularity net rise, which is, I think, a fair point. Like saying, yeah, every company is working isolated and they are not working in bringing connectivity. I think right now, for instance, all these cloud technologies, they are working more in collaborating and making compatible. So things that you have from one company, you can bring to another company. But regarding some specific narrow AI problems, you still have exactly the same problem. If you developed a specific algorithm for solving these, and you did not work in to make it compatible with other systems, then it's going to be difficult to connect them. You know what I mean? Unless there is an agreement in all of them working in some of a kind of a standard. But if there is no standard, then each company can work in their own and build their own ways of doing it. So it's going to be difficult to make it compatible.
Okay. There are a couple of more questions or follow-on questions. Supreet, you wanna pick them up?
Yeah, sure. So I think Pilar has another question. What do you think about hive minds?
Wow. I have not heard about hive minds. Could you be maybe more specific? What
Yeah, I
is
think
this about?
It's okay. So, Pilar, if you are listening to us, if you can please add more context in comments, but we'll take the next question. Until
Mm-hmm.
then, is AI also related to the study of psychology? Interesting.
I could say that since they discovered that our intelligence, our human intelligence, is very connected with psychology, for me, it makes sense that you try to consider also if you are trying to build human-like intelligence, that's when you should include psychology. But as I mentioned during the presentation, it is really complex.
Yeah,
So imagine to build an algorithm that you train it to solve some specific problem in a certain way, and now you need to add a new dimension, and it's that when this AI is interacted with another AI, it should adapt the reactions and actions depending on of the reactions of the things that is interpreting from the other AI. So it is in this very challenging, to do that.
it's true.
yeah. That's an that's really interesting. Point. Yeah, definitely. Um, I think we don't. Okay. Pilar has just responded on the
Mhm.
follow-on question on hive minds. So, Supreet, over to you. Yeah.
Yes, it's set of tiny, narrow, intelligent algorithms. Wow, collaborating more than a unique, complex
Ah,
intelligence.
okay. Yeah, yeah, yeah. Yes, I read an article about that. It's like building small intelligence or processors that they want to learn specific things, and then maybe one learn what type and then share it with the other, and then together can build a kind of a community share intelligence. I read an article just looking for the long tail problem from I think it's on the resources that I share on the slides. I will pass to you, Suprit, those resources for the people to read it. And there is this article from one person working for Google in trying to build this hive mind. In It was for a specific problem of opening doors. So it was a robot and a robot arm trying to open just doors, but different doors, different structures, and so on. And he wrote in the article that after working many years in that specific problems of building a hive mind to learn how to open doors, it was quite challenging and it was quite difficult to build. Because I think, again, we if we need to go to the way we humans learn, I believe that it requires this kind of intuitive engines or whatever intelligence to be capable of extending and extrapolating your intelligence to other cases. And in these hive minds, what they are saying is that I learn one thing, you learn other things, and then we put together and all the things that we are learning. But yeah, the article that I read, it was saying that it is going to take much longer than building, this core kind of intelligence. That was the I do not have experience in building hive minds, so I have to rely on people. But there was something on the screen, another question or a comment.
There is another, sorry.
Yeah. Yes, Supreet. Yeah.
There is another question that just came in, how machine learning and data science are related.
Well, the thing to understand AI is like AI is the whole umbrella of everything, okay? And then you have machine learning, which is below, and then you have deep learning. So in AI, is like we are saying, we are trying to imitate some intelligence or the kind of human intelligence. Then machine learning is when you are building, trying to learn, find this automatic processes and kind of make predictions and so on, learning from the data. And in deep learning is specific for these patterns, to find patterns in data. So data science is the science of using data to doing things, right? But it does not really means that automating things or whatever. You can use mathematical algorithms or things like that. So I would say that data science is maybe more generic, more like covering whatever things that you can do with data. And in machine learning, what you're trying is to make the process automatic and to also include some kind of intelligence or on the predictions and so on. So I know it's a very generic question, but for me it's like data science is a brighter field, and machine learning is more specific, more concentrated on doing more automation and automatic processes, automatic learning.
Yeah, I think that's a very good description of how machine learning and data science vary. Thank you for that. I think there's another question by Sashi. Use of machine learning is more in which sector?
Well, I got also the other day another question from someone saying, do you think we should use machine learning for all? She was kind of saying, I see that people are getting crazy. They want to use machine learning to solve any problem. It's like it's cool to say that we are using machine learning. So it's kind of connected with your question, Sashi. I do think that if you have a good solution for something, you don't necessarily need to build a neural network just to say to people, oh, I'm using a neural network to do this. It's expensive and it's totally maybe not the point. The point of using machine learning or these complex architectures and algorithms is to improve. So, or rather you want to improve the performance or you want to improve the speed, but you want to do things like faster or in a more intelligent way. And I used to also explain that with the way that people were doing data analytics and data science. So in data analytics, you just look always to the past data and then you analyze. So it's a kind of post-mortem analysis. But in data science, it's like you look to the past, but you look to the future too. And so you are trying to bring, some lessons from the past and try to use it for the future. So it's a more proactive way of doing things. And again, in machine learning, what you bring is even further. You want to improve and you want to do things in a more efficient and more faster way. So I would say now there is a lot of algorithms that are in different sectors, like insurance, or even in medicine. They are doing some researches on predicting, with images of cancer or so on, to try to predict things and illnesses. Um, I would say that maybe slowly we will be using in every sector. If you think about, we are using computers now for everything. So it's everything goes through an algorithm, through a computer program, and there is data behind that. And when you have data, you can try to find patterns, you can try to find and ways of doing faster and so on. So
Yeah, and I think in many cases we can also do things that probably humans are not able to do. For example, things like, I mean, would love to know your thoughts on it. For example, one of the things that we did at DeFi was, it was at Peking University. We did a challenge, which was around which was around forecasting earthquakes a week in advance. And these folks, they not only built up, it was a 10-year long research. They not only did get the model, they now deployed it in Middle East and China. So I think probably adding on to what you mentioned, I mean, maybe you can give a better perspective. AI can also solve problems that were initially not possible by human brains to solve in many contexts with the sheer
yeah.
power of data.
And another point, that I'm a very fan of Andrew Ng. I don't know if you know him. I'm also a mentor in deep learning AI from different courses. And he is saying in his last talks about democratizing AI. So it's like saying, because all these machine learning techniques and so on, it looks like it's only feasible or achievable for big companies. We should do it in a way that even small or middle companies are capable, or should be capable, of using AI and machine learning in their problems. It should not be so expensive, or so, like, for big companies that they do have a lot of data. It should be something for everyone. So, because in the end, we are all users. We will all be ending using AI in our daily lives, in the technologies and so on. So it should be a technology that should be, at the hand of everyone.
Yeah, definitely. um, there is a couple of more questions. Do we have time for them?
Yeah, I'm okay.
Yeah,
I
I
mean,
think we have 8 more minutes, so we can take two more
Yeah,
questions.
yeah. Preet, over to you.
Okay, so Tara has a question. Could you talk about MLOps?
okay, MLOps. Yeah, it's like, I can tell that there was this race of data science, all starting in 2000. I don't know, it was 14 or 17 or whatever. At the beginning, everyone wants to do something with data. They just wanted to have people to just analyze data and try to find something intelligent or interesting from the data. And they were trying to build models and so on, blah, blah, blah. So at the beginning, the companies were putting a lot of effort in having people capable of finding intelligence or something in data. But then they realized, okay, I have now a model and I need to put it into production. So when you need to put that into production, that's not only about algorithms or mathematics or cool uh, visualizations of data points and so on, but it's more engineering, in a way of, you need to script, you need to monitor, you need to really scale the thing. And that's when they started to realize, okay, we need someone that is not only a data scientist, but it would be more like an engineer. So sometimes they call it data engineer, but now another name is MLOps, like DevOps. So it's like the DevOps, but in machine learning. So right now they are quite demanded at the job market, because, as I said, like some years ago, companies were hiring a lot of data scientists, but some of these people, they come from universities or whatever. They are mathematicians, or they are, I don't know, biologists, or whatever, people with a lot of statistics and theory, but maybe they do not have so much experience in programming or engineering. So that's when they need someone with that knowledge, but they need to apply it to some specific machine learning models and machine learning problems. It was a long
Great.
explanation, but
No worries, no worries. I think let's take one more question and then we can conclude it. So Sashi has
Mhm.
a question. In data science, is it more of creative mind used or our logical mind? Oh, okay, interesting.
Do you mean that we are using more our creative mind or our logical mind? I could say both. I mean,
Yeah,
because yeah, you need the logic, you need like kind of the mathematics, or the approach, the systematic approach to try to find a solution. But then sometimes you face things that you were not expecting, like life, right? Life always surprises you, and then you need to solve the thing. And sometimes that's not on the books, or that's not on the Stack Overflow or whatever. And then you just need to use your own experience or your creativity, just call it whatever you want. But yeah, definitely I do think that data science is a very creative job.
yeah, yeah. And I will add on to that, right? Like, if you are a data scientist day in and day out, I think you also need to think like a business leader. So you need to have vision
Hmm.
for the problem that you're trying to solve. So definitely your creative juices are on most of the time.
Yeah, and sometimes clients come to you and they say, "Oh, because I read that article or whatever, I think we could use this fancy solution, whatever." And then you need to listen to them and say, or to hear them and say, "Okay, what do you want to solve? Which is the problem you
Yeah,
want to solve?" And then they
yeah.
explain you, and then you need to come up with saying, "I do think that maybe we can do it in another way. You don't need a neural network for that, you know?"
Seriously, that's so true.
Yeah.
So if you all have any additional questions, feel free to reach out to Rosa. She's very active on LinkedIn, and she won't mind. So we will just conclude the session. Thank you so much, Rosa, for your valuable time making this. I
Thank
think
you,
it's one of the
everyone.
most interactive sessions that we have had. People have asked so many questions. Thank you so much for that.
Thank you so
Thank
much,
you.
Rasa. Thank you, Supreet. And thanks to everyone watching. We would love to see you again next Saturday. And happy
Yes.
learning, happy weekend. Bye.
Yes. Bye,
Thank you.
everyone.
Bye bye. Thank you.